Welcome back. It's kind of sad that the Olympics is over, and I enjoy watching the games every day. And I don't know how you guys been watching the Olympics. Recently, I watched this gold medalist from India called Neeraj Chopra. I'm sorry if I butcher this pronunciation, but if you're from India, please help me to correct the pronunciation. But Neeraj Chopra. Wow, that was like very emotional moment. I was really touched that he won the first gold medal for India. That was I love watching other countries than China, U.S., or Russia winning medals. It's just very touching moment. Anyways, Olympics is over. We still need to carry on and coding. Actually, I hope that coding can be part of the Olympics because that would be another chance for China to win more medals. Anyways, and India too, right? India will have more chance, opportunity to win coding medals if there is a coding competition in the Olympics, and it'll probably win all the medals too. Anyways, reverse integer. It's gonna be an easy question, so easy here. So let's get started. Resume. Thank for my fan to thank my fan for recommending me this website. They have some creepy ads, but now that I'm able to see the time on the tab. Wait. 42, 41. Okay, it's running. Right. I thought it froze for a second. So, okay, let's get started. So, given a assigned 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the assigned 32-bit integer range, so which is -2 to the power of 31 and 2 to the power of 31 then minus 1, then return 0. So if it's outside of the range, 32-bit range, then so assume the environment does not allow you to store 64-bit integers. Okay, all right, this is a weird restriction. So let's see. So we have input 1 to 3, mark it easy. Return 3 to 1, negative 1 to 3, return negative 3 to 1, and 1 to 0, return to 1 because 0 is in the front, which doesn't make up a number. X is 1, 0, and then we'll have 0. Okay, so first of all, we can come up with mathematical approach, which is we can go through we can start from the rightmost digit, and then we will have a counter called tens, right? So the tens counter starting from let's say from 1, and then every time we move to the left, we will increase the tens timer, right? So 3 times 1, and then 2 times 10, and then 1 times 100. So, and then we add them up. So this is the mathematical approach. And but since we're doing Swift, I feel like if we do this mathematical approach, we are not unleashing the power of Swift. It's like we are playing with Pikachu, but we don't release the lightning, right? We just keep hitting A, B. Like we're playing Mortal Kombat, but we're just hitting the fist and the kicks. We don't release the Hadouken or like Kame Kame Ka, like play Dragon Ball Z, right? Now nobody plays with only just kicks and punches, right? Like we play Dragon Ball Z for the Kame Kame Ka. Anyways, so I'm gonna skip the mathematical approach, and I'm gonna use some Swift specific functions for this. Okay. So let's see. So first of all, if it's a 0, we can just return 0, right? So if x is equal to 0, then we can just return 0. So we save all the calculation. And then the solution is that we are going to convert it to a string, reverse the string, and then convert it back to an integer. Now you're probably thinking, like, what about like this scenario, 1 to 0, and then we reverse the string, becomes 0, 0 to 1, and then what will happen if you convert it to an integer in Swift? Well, Swift, it's pretty smart. It's smart enough to interpret it 0 to 1 as 2, 1. So it's taken care of this part. So first of all, let's convert this to a string and then reverse it. So we can convert it to a string, and then we can reverse. It will return a reverse. So according to the definition, reverse returns a sequence. So yeah, it returns reverse collection. It returns a collection. So you need to wrap it up, convert it again to string by doing this. Just making sure I'm not making any mistakes. So convert it to string, reversed, and then we will let's do let first. Let's do reversed string. Okay. So now there is another problem, is that we have a sign in front of the number. So why don't we let's save the sign first, right? So let's see. Let sign is equal to x divided by absolute number x. Okay, so because we already checked 0 here, so we won't be dividing 0, so that's good. So this will be the sign, and now we can convert. We don't have to worry about the sign. So absolute number reverse string, and then reverse. I think you need a parentheses right here, right? Parentheses, yes. Okay, I hate this new UI because LeetCode new UI, because like why would you put like parallel to the coding pad parallel to the question? That doesn't make sense. Okay, anyways, so now we have reversed the string. We can return the integer reversed string. So there's and the integer function returns a, make sure I still have to. So the integer function returns a optional. So we need to make sure that it doesn't fail. And so if it doesn't make sense, if the number doesn't make sense, we'll return 0. What else? And we will need to multiply it with the sign. Okay. And what else? The value go outside signed 32-bit integers range. So we need to make sure that the range is within, the number is within this range. So I guess we need to create another number, because we'll need to get the numeric value first, and then we need to determine whether it's within this range. So we will do this in another line so that the line won't get too long. So we'll say call it result is equal to this, and if it doesn't make sense, we'll convert it to a 0. And here we'll do oh, actually, yeah, we can time sign here. Okay, and okay, so return if result is larger and equal to int, it's 32, right? 32 dot min, and result is less than and equal to int 32. So this is the handy part of Swift. Like it immediately gives you the maximum minimum of the corresponding bit, compared to Java. It only gives you the 64-bit, I think. Anyways, so max, and so if it's within this range, then we can return. But if it's not, we can return 0. Okay, we only have 4 minutes left. So let's see. Pretty straightforward, huh? Oh, I can't believe I've... Okay. This is not Java, so I keep getting confused by Java. Except, so 1, 2, 3, 3, 2, 1. Okay. Looking good. All right. I guess we can submit it and see if we pass. Oh. Accept it. Yeah, faster than 88.59% of the Swift online submissions. Okay, cool. So we still have 3 minutes left. All right. I spent too much time talking, but this could have been finished within 5 minutes. Yeah. So this is. If I were to categorize this question, this would be categorized into string. So this is the power of Swift, right? We use the Hadoken or the Kamehameha of Swift on this question. So this is reverse string, instead of just using the very straightforward mathematical approach. Anyways, thanks for watching, and I'll see you in the next challenge.